As you can see in this problem, I've written our system of equations slightly differently. I've written our system of equations horizontally because neither of the equations reads that x equals something or that y should equal something, which is a change I'm going to have to make before I start, which is why I've written them horizontally. As you can see, the system of equations reads y minus 3x equals 5 and x plus y equals 3. I'm going to have to choose which one I want to change, and the one you want to change is simply a personal choice. You can choose to change the first equation, or you can choose to change around the second equation. I'm going to choose to change around the first equation. Furthermore, I'm also going to choose to have y be the sole survivor, or in other words, I'm going to make the equation read y equals something. In order to do that, that means I'm going to have to move 3x to the other side of the equal sign. As you can see, there's a subtraction sign in front of the 3x, which means I'm going to have to add 3x to both sides of the equal sign. So, I add 3x to both sides, which cancels it out from the left side. And on the right side, it doesn't really have any impact. It's not going to combine anyway with the 5. They're going to remain separate entities. So the equation is simply just going to read y equals 5 plus 3x. Now, I can't choose to plug that back into the equation it came from. It's going to have to get plugged into the other equation, which means it's going to have to get plugged into x plus y equals 3, where y is. So I'm now going to change y into 5 plus 3x. So the equation will now read x plus 5 plus 3x equals 3. Now we know at this point I want to start combining like terms, meaning I want to put the x and the 3x together. So if I have 1x and I add 3 more x's, I now have 4x. So I now have 4x plus 5 equals 3. We also know that we like to move constants or lonesome numbers to the right side of the equal sign, which means that the 5 is going to have to get moved over to the right side and joined together with the 3. As you can see, there's an addition sign in front of the 5, and we know in order to move something to the opposite side, we have to use the opposite operation, which means I'm going to have to subtract 5 from each side of the equal sign. When I do that, I get 4x equals negative 2. And I have to now solve that equation. That equation is, of course, a multiplication equation, which we solve simply by dividing. And I'm going to divide across by 4 at this point. When I divide across by 4, I get the fact that x equals negative 1/2, or as a decimal, which you probably have if you used a calculator, that x equals negative 0.5. Now at this point I get to move back to the start as I've done in earlier problems. I can choose to work with y minus 3x equals 5 or x plus y equals 3, whichever one looks shorter to me. X plus y equals 3 does indeed look shorter, so I'm going to choose to work with it. We just learned from the first part of this problem that x is equal to negative 1/2. So I'm going to change x into negative 0.5. And I'm going to leave the y and the 3 alone. As you can see, I now have to solve that equation to find the value of y. In order to do that, I'm going to have to move this 0.5 to the right side of the equal sign. As you can see, that 0.5 also has a negative sign in front of it. Remember, as we've said many times throughout the year, a negative sign looks like subtraction, and the opposite of subtraction is addition. So in order to move it, I'm going to have to add 0.5 to both sides of the equal sign. And when I do that, I get y equals 3.5, which is the other part of the answer. So I now have my final answer, x equals negative 1/2, or negative 0.5, and y equals 3.5, which we could write as the coordinate pair negative 0.5, 3.5.